Good morning, class. My name is Jose del Castillo. This is my contact information. Today we are going to be covering a motor industrial motor controls, unit 1, day 1. And we are going to be learning how to use the very important tables on the National Electrical Code book. The table 420.50, which is used to determine the full load ampacity for a three-phase electrical motor. Then we are going to be using the table 420.52 to determine the rating of my protection. In this case, we are going to be using fuses, time on delay and dual element time delay fuses based on that table. So these are the two tables that we are going to be using. The 420.250 and 420.52. Okay, so using those tables and this example that I have here on the whiteboard, we are going to be able to learn how to determine the short circuit protection. And the second part of this lab will be how to determine the proper gauge for the feeder electrical conductors. Okay, so the lab equipment that we need is, there is no equipment that we are going to be using, but however, we require pencil and paper and a calculator. And my resource will be the National Electrical Code. Okay, the National Electrical Code. This is my resource, and the two tables, as I told you, that I will be using is, this is one, 420.50, 420.50, and then this table is used to determine the full load ampacity, okay? And it's based on the horsepower on the first column, and then depending on the volts, the voltage that we are going to use to feed up the electrical motor. In our case, we are going to be using 480, three-phase, of course. And then we are going to be using the table 420.52 to determine the rating on the fuse, which is my protection for the short circuit. That is the first part of the lab. The second part of the lab, knowing the full load ampacity, we are going to use the table 310.15 parenthesis B parenthesis 16, or the table 310.16 to determine the gauge of the feeder. Let's start on this. Okay, so the first thing that you have to determine is the volts that you will be using. This one, 480, and the horsepower. This is 15 horsepower, 480. Okay, for 15 horsepower, 480. Okay, according to the table 430.50, 15 horsepower, the full load ampacity is 21 amps. 21 amps. And for the second motor, okay, 480 three-phase, 50 amperes squirrel cage, 50 horsepower. For 50 horsepower, according to the table 420.50, the full load ampacity is 65 amps. For 10 horsepower, working with 480 volts, the full load ampacity will be 14, okay? And for the 100 horsepower, the full load ampacity is 124. For 20 horsepower, the full load ampacity is 27. For 5 horsepower, is 7.6. Okay, so how do I determine the fuse rating? Well, depending on this, the first one I want to use non-time delay fuse. If I go to the table 420.52, okay, so for 15 amps, okay, so for 15 amps, so I need to use, see, okay, right here, I need to use, hold down, let me double check, okay, it's 14, hold down, let me double check here, calculation. Yes, it's correct. So for 15 horsepower, according to the table 420.50 is 21 amps. For 21 amps, so if I want to use 21 amps, which is 15, this one, so, and I want to use non-time delay fuse, I need to multiply 3 times the full load ampacity, which is giving me 63 amps. I don't have a 63 amps fuses in the industry, so I round it to the nearest higher, which is 70. For the next, which is 50 horsepower, the ampacity is 65 amps. So, and I want to use, in this case, dual element, time delay. So I need to multiply the full load ampacity times 1.75. Okay, keep in mind the table is giving you the percentage. So for example, in the previous example is telling you 300 and 300%. So how do you convert this into factor? You divide it by 100 and remove the percentage. This will be giving you 3. Remove this and 3. So that is the factor here, 300%, 3 times the full load ampacity, which is 63, for a total of 70 amps. So the next one is 65 amps, which is the 50 horsepower. The full load ampacity is 65, and I am asking you to use a dual element time delay, so the factor is 175%. How do I, the percentage, how do I convert this into factor? I divide this by 100 and remove the percentage sign. So what I will have is 65 times 175, which is 113.75. I don't have 113.75 fuse, so I will use the nearest higher one, which is 125. Then for the next, which is 10 horsepower. The 10 horsepower, according to the table 420.250, working with 480, the full load ampacity will be 14. And I am asking you to use non-time delay fuse. So I need to multiply the full load ampacity times 3, which is 42. I don't have 42 amps fuse, so I round into the nearest higher one, which is 45. So you won't find 42 amps fuse in the industry. So we select the nearest higher one. So for the next, which is 100 horsepower, the full load ampacity, according to the table 430.250, and my motor is connected to 480 volts, 3-phase, so the full load ampacity is 124. So 124, okay, and I am asking you to use dual element time delay, so I need to multiply it by 1.75, according to the table 420.52. So it's giving me 217 for rounding to the nearest higher one, which is 225 amps. So for the next one, which is 20 horsepower, according to the table 420.250, this motor is connected to a 480 volts three-phase. So the full load capacity for that one is 27, and I am asking you to use non-time delay fuse. So I will multiply the 27 times 3 for a total of 81. So I round into the nearest higher one, which is 90, and then the last one is 5 horsepower times 7.5 horsepower, according to the table 420.250, working with 480 volts AC. The full load capacity is 7.6. Now, I use the table 420.52 and the type of fuse, non-time delay. So I need to multiply it times 3, which is 22.8. I round into the higher one, the nearest higher one, which is 25 ampere. This is the rating of the fuses that I need to use for my electrical motor. This is the way that you determine the short circuit protection, okay? Short circuit protection for electrical motor. This is the objective that you learn. So in conclusion, the first thing that you have to know is your resource. NEC, which table? For electrical motor control to determine the full load capacity, 420.250, three-phase electrical motor. Then you have to determine the voltage that you will be applying to the electrical motor. In this case, 480 three-phase, using those and the horsepower. Your table, the volts and the horsepower. So having this resource and these two data, you determine the full load capacity. Okay, for example, on 15 horsepower, the full load capacity is 21 amps. What is the size of my fuse? I go to the table, 420.52. Okay, and I need to know if I want to use non-time delay or dual element time delay fuse. In this case, it is non-time delay fuse. In that table, on this table, is asking me to multiply the full load capacity 21 times 3. And this is the way that we work to determine the short circuit protection. In this case, we are using fuses, okay? Fuses. And don't forget, a fuse is offering higher protection against short circuit. A circuit breaker could be 10,000 amperes. Fuses, some of them could be up to 250,000 amperes on a short circuit. A circuit breaker responds in 3 seconds. Fuses respond in 3 milliseconds when it's a short circuit, or a little bit higher, 3 or 5 milliseconds. Okay, so from this point of view, for short circuit, my best option is a fuse. Okay. That is what I have for this, the first part. So the second part will be determine the size of the feeder and the size of the feeder, the gauge of the electrical conductor feeding up all my electrical motors.